Hi guys. Okay. So first of all, hi everyone. Hi Shreya, Akash, Ashish, Smile Mania. Good to see you again today. I think it's your second day of attending this live session. Uh, well, Anmol, Anmol Tomar. I think it is first. Is this your first time? Ashish, hi Ashish, Pratik, Ritik, Ashish again. Hi Rishi. So, first of all, sorry for being a little late, Shreya. It's not going to start at 12 or 1, although it would be much more feasible for me, but nahi, I'll not start it at 12 or 1. Okay? So, don't worry about that part. So, probably, like, if we are late, we'll be late by 10-15 minutes, not much. Hi, Surbi, Apurva, Akash, Adarsh, Akash, different Akash. Good to see you all. So, ठीक है यार, let's get started. Uh, Again, I think what I've done is like I've added a bit of a complicated question. In fact, almost all were difficult ones today for a beginner, but for someone who is basically for a lot of us, for a lot of you who are at a decent stage, it would not have been very difficult questions. So what I will do is I'll probably go over this sheet one more time on this weekend, Saturday or Sunday, whenever that is, whichever day that is. I think that will be 9 or 10, and go through it one more time so that it's in the correct order. Okay. Without any further delay, let's jump right into it. There were more people when I so there were 15, 21 people waiting, and now it's just 10. Did people drop because I joined? That's weird, right? Okay, so let's get started. So, how many of you actually, if you have done the question before, I think 12, you would have seen four questions, but I moved one question at the out, and there were only three questions, out of which one was also a recursion question. And I will give a leeway again to recursion question, and we will do this question again when we'll cover recursion. How many of you were able to solve all the questions today? Pratik is saying that was the easiest question. Apparently, if you know the concept, it was easy, but not for all. So there are three questions only. The questions are jump game to maximum point that you can earn and combination sum. How many of you were able to solve all three? Yes. So how to? Yes, it requires backtracking, and like I said, I'll give a leeway again for backtracking question, and we'll try to not discuss it in this session, and we'll only discuss two questions, which is jump game two and maximum point that you can earn. In fact, both of these questions are really interesting questions, and it'll be a good learning session for new people. Okay, nice. So without any delay, let's jump right into it. Uh, मेरे पास notebook नहीं है. No worries. Before we start, there is one thing that I'll like to say, and that one thing is basically, uh, so first of all, congratulations to, I think, Akash got a call, Suresh, and I think Surbi, or Soumya. I don't remember the name of that girl. But congratulations. I got a confirmation from the manager as well that you guys got the test link. So give your best, do your best, and let's hope for the best as well. So, and I'll keep posting these opportunities like these in the group. So be active in the Discord community. I'll keep posting things about these definitely. So Soumya Tiwari, sorry, not Surbi, Soumya Tiwari. So yeah, let's jump into it now. So the first question that we have today is jump game. So let's see the question and let's try to solve it then. So the I don't have a PPT today because I literally just ran from the office for this live session and I was not able to prepare anything today because of the work. So the question is, you have been given an array of integers, an array of integer which represent the number of jump that you can take from this position. From here you can go up to two positions, which is 3 and 1. From 3 you can go to 1, 1, 4. From 1 you can go till 1, and from 4 you can go anywhere, but you don't have to because 4 is the last element. So let's take the second example. For 2 you can go to 3, 0. For 3 you can go to 1, 0, 1, and 4. For 1 you can go to 4. So this is the question. What you need to find is how many jumps will it take for you to reach at the last of the array. Okay, so you are standing here at the beginning of the array. You need to find how many steps will it take to make for me to reach last of the array, right? So this is the question. So now let's see. I have a question before we. Let me do one thing. Let me share my entire window instead of this. So 2, 3, 1, 1, 4. So assume this is the array. Just ignore the big 4 cell. So if this is the array, can I always do the greedy? Like, can I directly jump to the last and is this optimal? Like, go to the maximum possible solution and then basically go to the maximum possible solution and from there go to maximum and then from there go to maximum. Do you think this is good enough? Okay, actually, one thing I missed is like I should take a step back and let's try to see the brute force approach of this first. Okay, let's understand the brute force approach and then we will see how can we optimize this. So let's try the brute force approach. What will be the brute force approach? What the hell? Yeah. So what is the brute force approach? Two, three, 1, 1, 4. The brute force approach is you start from here, you go to every possibility, and from there you recursively try again. You go to 3, you go to from 3, you go to 1, you go to 1, you go to 4. For 1, you also go to 1. You basically recursively try every possibility, right? So what will be the time complexity of this approach? This is a bit tricky question, but whoever gets who has decent understanding of time complexity concepts will be able to understand the time complexity. Okay, Krishna Coder, like whatever the pronunciation is, says it's n square. Is it n square? Guys, we're talking about brute force. First of all, let me repeat. So, what I did as a brute force. So, we start from here. We first go to this, then this. Sorry, first we go to this, then we try all possibility for this. Found one solution. Okay, updated. Then for this, we try again. For this, we try again. So this is actually not n square solution. This is an exponential solution, n to power n solution. Right? This is an exponential solution. So yeah, this is what it is. Like what happens is you have to backtrack every time here. That is the brute force solution. Right? Now let's try to see how can we do better than at least brute force. Is the brute force solution clear, and is it clear why is it not polynomial and why is it exponential? First of all, tell me yes or no. Okay, awesome. Now the second part is Manjul says tell again. Okay, so first of all, we are here. I'm talking about brute force again. So from 2 I will go to 3, and I will also go to 1. From 3 I will go to 1. This one, is there a way to delete this thing in how does someone delete it? ये होना चाहिए. Yeah. So from here, you go to here and here. From 3, you go to 1, 1, and 4, all three possibilities. From 1, you go to this, and sorry, here only. But for 1, you go for 2 and 3 both. From this 1, you go to 2 and 3 both. This is a brute force solution. This one, you always also go for this 1 and this 3, right? So what you're trying to do is just DFS kind of thing. Brute force solution mein you are going deeper into it. Right? This is why it is exponential. Clear? Manjul, is it clear to you? Okay, so let's move to the next part. My next question was, from here, can I do something like, since I can go from 2, I can directly go to 3, this position, I will go here. I will take the best possibility. From 1, I will go to again best. And then from here again, I will go to 1 best. Is this is a greedy approach? Do you think this is most optimal or this is right approach? So, and since your answer is no, tell me why not. Why will it not work? Pratik says this is one of the way, but not optimal. Is it always going to yield correct result? That's the question. Let's say I'm not even worried about number of steps. Will it always yield into me reaching at the end? Correct. This is not, this is suboptimal. Along with that, this is incorrect as well. Let's say if here it was 0. In that case, I will jump to this and now I can't go anywhere. Whereas if I had jumped to 3, I could have jumped directly to 4, or in fact in even 1. Right? So yes. So now the reason being, you may end up missing a bigger number in between. And that's what Manjul is also saying. Right? Okay. Now let's see how can we do this. Now let's assume only this much array was there. This much. What we will do is, I can always reach my this index in 0 number of steps because I'm standing there. Here, when I am on 3, at 3, what I will do is I will go to past. I will go to past and I will try to see uh, what is the best that I can reach onto this 3. Okay, so how can I reach 3? From this point, can I reach 3? Yes, I can reach 3. So I will just add 1 to this, which is 0. Here 0 plus 1 is 1. What is the current number? Initially, assume that null is basically infinity. So I will add 1. Let's say if there was one more element here, and for some reason, let's say that was also 0. And okay, not let's not add it. Let's move on. In the next step, you'll be understanding this better. So now this is it. Now when we are here at, let's say if this is the only array that we have, now at ith index, how can I reach I can reach from 0 to I minus 1, say, in one jump. So I will only look at the numbers from which I can reach here in single jump. Okay, so from I minus 1, from this number 1, 1th index, can I jump to 2? This is 1 index, this is 0 index. Can I jump to 2? Yes, because I can take 3 steps here. So I will jump, I can jump. So what will be the answer of it? This plus 1, because I need one additional jump, right? So here plus 1. So what I will do is I will add 2. Is 2 less than current number? Yes, it is less. Why? Because 2 is greater than, smaller than infinity, right? Now I will go back. I will go to this 2. Can I jump from this 0th index to 2? I can, because 2 plus 0 is 2, which is correct. So what will be the number of jump? 0 plus 1, 1. Is it better? Yes. So I will update my answer. That's it. Move to this index now. This is 1 again, 3. Can I jump? Again, I will go from I minus 1 till 0. Can I jump from here? Yes, I can jump. So what will be the answer? 2. Can I jump from here? Yes, I can jump. What will be the answer? 2. No updation required. Can I jump from here? No, I cannot. Move on. Can I jump from here? End of discussion. Okay, let's go to this. 4. Now, how can I reach 4? Can I jump from here? Yes, I can. So 2 plus 1, 3. Then can I jump from here? No, I cannot. Because 2 plus 1 is equals to 3 and this is 4 only. If I can reach that index, good. That is the only time I consider it. Can I jump from here? Yes, I can jump from here. 1 plus 3 is 4, it is 4. What will be the number of jump? 2. So is it better? Yes, it is better. So I will update it to 2. Now, since the array is over, whatever my result is there in this sub array, I will return this. So the answer for this question is 2. So the answer is, this answer is 2. This is the answer. Is the logic clear to everyone? This may be a little too much to take right now. Is it clear to everyone? If it is, what is the time and space complexity? Let's see the code of it. And since I literally just came when we were doing this discussion, let's see how what was the quality of code that I wrote. DP is this. This is actually kind of DP, but you can say very, 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 very easy DP. Not a true DP in a sense, but yes, theoretically it's DP. What is the time and space complexity, guys? Okay. Can we do better than this? In fact, I've done better than this. There's a 2 millisecond solution as well. When did I solve it? 2019. Why it's n square? Good question. So now, if you see what I'm doing is from 1 to n, this is not n over time, this is n square. So what I'm doing is for I am going from 0 to, for j, I am going from 0 to I. For every I am going from 0 to I. That is why it's n square. There is a better solution. And we will discuss that better solution now. So what is the time complexity that you solved it in? Like all of you, whoever solved this question, what was the your best case time complexity? You can do it without the DP aspects as well. And that is a sort of a greedy algorithm, but not the way we solved the greedy. Okay, let's do it in ON now. Let me refresh this because this is really dirty. Okay, now what we will do is we'll try to optimize this. So from exponential, we came to n square. From n square, we will go to O of n type of solution. Okay. Now, can I say from this index, I can jump to 3 or I can jump to 1? Can I say that? Since I can jump to 3 or 1, I have to pick a best choice of it. So, and clearly, best choice is 3, right? Why? Because from here, I can jump the maximum in future. So, what I'm doing is I'm trying to come up with the best choice that I can jump onto. So earlier in my previous solution, what I was trying to do was I was jumping on my current index from the best possibility. Now I am doing it the other way around. I'm trying to jump onto the best possible answer. So can I say I plus A of I? Sorry, A of I. If I maximize this, that will be my best answer. Let's see this in action. Let's see a different case. 2, 3, 2, 1, and so on. Let's take it as 3. and let's take it as 2. Now from here I can go to this 3, I can go to this 2, and I can also go to this 2, right? So now let's see, what does this mean? Ki I plus a of I, for, or j plus a of j, j plus a of j is what I'm trying to optimize for. Now from this point, where can I go at max? Here. From this point I can jump to this 2 and this index. From this 2 I can jump to this. Let's take a different color. I can jump to this and this. And for this 2 I can with, so this is same. From this I can jump here and here, right? So basically what it means is, at any point, if I try to make the best possible jump in the future, I will have better solution. Because जो भी मैं यहाँ इससे कर पा रहा हूँ, वो तो मैं इससे कर ही पा रहा हूँ, बट एडिशनल चीजें भी कर पा रहा हूँ और एडिशनल जंप्स भी कर पा रहा हूँ, राइट? So this is what I try to optimize. J plus A of I. This is what I try to optimize or maximize. If I try to jump onto index which is greater, or for which j plus a of j is maximum, I will go to that, and then next, and then next. So why will this work? Give me a reason, guys. Why will this work? Or why, if you think it will not work, why will it not work? I've already explained it, but I want to hear it from you, if and check if you guys are actually listening or not. That's correct, Akash. So, Ritik, even in that case, it will not matter. Like, let's say if this was 1, you can go to this point at max, you can pick anything. So, it is like in equality, I will pick the farthest point. That's up to you. So, Pratik, Apurva, that is good. This is what we are trying to do. So what we achieved doing this is, like, I want to know from which point can I go the farthest, like what is the point from where I can jump the farthest in the future. This is what I wanted to achieve, and this is what I got from this. Let's see its code in action. uh, okay, now the code is basically here. I am going from 0 to n, and I am trying to maximize this. That's all I'm doing. J is the number. I'm going from I to I plus j, and also obviously this check is important, and then k less than n, because otherwise you'll end up in out of bound exception. And I'm just trying to maximize my max, and wherever I go, I just jump directly to max k. That's it. That's all I do. What is the worst case time complexity of the solution? Worst to worst case, like think of a worst case and tell me the time complexity. Hmm. So in worst case, it can go to n squarish, but it's actually not n square. But yeah, effectively in big O notation, it will be tending toward n square, but it's actually never going to be true n square. Why? Because we are, as soon as we hit the last, we have hit the jackpot and we have hit the answer. So that is why it is never going to be the point, or it is never going to be worst case n square. But yeah, theoretically it will be. But good thing is, like in most of the cases, it will be much faster than what we discussed last time. And you can also see that in action. Like, this is the solution that I solved, and it worked in 2 milliseconds, whereas the rest one works in 200 plus milliseconds. So it's much, much, much faster than the previous approach that we discussed. Is this clear to everyone? Is there anyone who does not understand this? Okay. Then in that case, let's do one thing. Let's move to the second question. And the second question that we have is maximum points that you can obtain from the card. So, how many of you were able to solve this question? This is a really, really interesting question. It got asked by one of the like companies from the name like Amazon, Google, Facebook, Microsoft. One of these companies asked me, like literally, this got asked to me by one of the team. So, who was able to solve the question? In the meantime, while you answer this, Mike, let me try to explain the question. So, the question says you have been given the array represent the points that you can earn by picking that particular element or that card, and there's a constraint. You can only pick from the end of the array. Either you can pick from the start or you can pick from the end. That's the basic requirement of the question. Either you can pick from the start or end, but you cannot pick from the middle. You cannot pick six, cannot pick two without picking one from each side. Now, what you need to do is you need to find the maximum sum that you can get by picking k cards. You can pick up to k cards. You have to tell what is the maximum sum that you can get from it. And while you guys are answering the way it will be solved, I'll try to answer why part of it, like the intuition behind this technique. Okay. Now let's see the question. So intuition. So first observation is, I've already mentioned, it is given in the question that you can pick from the beginning or end of the row, which means unless and until you pick one, you cannot pick two. Unless and until you pick this one, you cannot pick six. Unless and until you have picked six, you cannot pick five. So now what it means is, what does it mean to our solution? One के बाद ही we can pick two. Now it means after two only we can pick three. After three we can pick four, right? What it means is everything that I will pick will be a continuous block of elements. Similarly here as well, 6 1. But there is one catch. The catch is I can pick 6 1 and then 1 2. This 1 2, or this 2 1 and 6, like 6 1 and 1 2, or 5 6 1, or 6 1 1, or 6 1 1 2 if the count is 3, or 1 2 3. So this is the catch. So that is why it becomes sliding window. Why? If you see, what I can do is I can at max pick this. So three elements. What are the three elements from the last? I can pick these three. What are the three elements from the first? These three. Now let's say I picked this one first. This pick this one first, and this, then I can decide six or one, right? So let's say I picked one. Now I can pick six or two. But again, in any case, it will be a continuous memory, right? Because, like I said, the question says you can only pick from the end. So it has to be continuous memory. That is why it becomes, this is the reason it becomes sliding window maximum kind of question. And that window becomes circular. Let's assume this is the array. And sorry, what was the point? 1, 2, 3, 4, 5, 6, 1. 1, 2, 3, 4, 5, 6, 1. Now you can pick these two from the last and this one from the first, or you can pick these two from the first and you can only pick one from the last. So these have to be continuous memory. If we consider this as a, if we consider this as a circular array, then this becomes the sliding window question. Is this clear? Like why how does it convert into sliding window question? Is there anyone who does not understand this? Okay, let's try to put it in a different form. This intuition is important. Now, one thing is you can pick one, and that is the only time you can pick two. Only after picking one, you are eligible to pick two. You cannot directly pick two without picking one. Is that clear? Now I can pick three only after I've picked two, right? So this is also something that I can do. Now the point is I can only pick continuous set of memory, continuous block of element, because I cannot pick something like 1, 2, and 4. Let's not worry about coming from the last. So I can only pick 1, 2, 3, 4. I cannot pick like 1, 2, and then 4, right? What it means is I can only pick continuous block of memory. Now, since I can also pick from the last, I can ignore this 4 and I can pick here. But again, this will become first part and this will become the second part of the array. This will become the first part, right? Let's say not picked one, I choose to pick from the back. So this is what it will become. I can add 6 only after picking one. If I remove 2, I can add 5. But I can only add 5 when I've picked 6. I cannot directly add 5 because it is not allowed. You can only pick a point or a element once that is out of once its right end or left end is clear, right? So if you see closely, you can pick this, or you can pick this with this, or you can pick this with these two, or you can just ignore and pick these three. Is that clear? All you need to do is, you have a window, you have, let's say, this window, you find max of find some, remove this, add this, calculate sum, calculate max, remove this, add this, calculate sum, calculate max, remove this, add this, calculate sum, calculate max, and return the max at the last. Is it clear, everyone? What is the time complexity of this solution? Correct, guys. This is O of n. Why? Because I can calculate this once, and now I just eliminate and add, eliminate and add. At max, I need to go to k times, because I can do k. I can pick k window size. So it is always going to be O of n. In fact, O of k. Yeah, this is going to be O of k. So that's about it. That's the question, and the solution that I have written is very different. I used it. I did this using DP, but definitely this is a better approach, and this is a much easy to understand approach as well. So we'll not go deep into this approach. So that's about it. I think we'll not go into the combination sum wala question today, because like last time, we did not. I did not have not covered backtracking and all, so we'll not go into details of that. So guys, that's about it. Do you have any questions that you guys want to discuss? We can do it for next 1 or 2 minutes, and then we can drop. And in the meantime, I saw a question, Akash saying this question can be solved using Owen approach as well. So Akash, I honestly don't remember the exact, like, strict Owen approach for jump solution. Let's do one thing. Let's take that forward in our Discord community. I'll probably start discussion in a while. So yeah, yes, Pratik, same thing. You guys are saying it. So let me do one thing. I honestly solved this question very around few days back. So I'll take some time. I'll think about it as well. You guys can discuss in the channel. I'll not look at the solution myself, because I want to do it myself as well. So probably I might be missing something. It's been a while. So let's discuss this in the Discord community in some time. But yes, you guys get started with that, and probably I can connect and join the session in a while. So yes, how to? Yes, I will give you leeway for all the wrong, like wrongly added questions. That basically the mistakes, or slash, you can say, extra questions that got added earlier in the stage than what it should actually have been in the later stage. So yes, you will be given leeway for this question and last time added recursion question, but not for any other question. And this is true for everyone, not just him. This is true for everyone. Any other question, guys? Chalo, in that case, I'll just take a pause here. And again, thank you so much for joining in. And do share the channel, share it with your friends and network, and subscribe to the channel if you have not done it yet. So thank you so much, and see you in the next video, or see you tomorrow. Okay, one thing, I'll take this question before we leave. What happened to the last duplicate number question from the list? I added this in the later stage of the challenge. It was supposed to be covered after a theoretical part, but yes, I added that later in the stage. So yeah. Were you able to solve it during interview? Because I was when I was solving it for the first time, it took hell from hint. Purva, to be honest, I have solved this like multiple times, so that might be the reason I was able to solve it. But generally speaking, I am able to solve question a lot of time. Most of the time, not 100% of the 100% time, but most of the time I am able to solve the question in an interview. But I don't remember for this one. It's been quite a while, at least 4 years. So I don't remember exactly what happened in the interview. And one more announcement. So probably 99% of the with a 99% chances, we will be doing a live session with a Google interviewer. Sorry, yes, he's an interviewer as well. So a Google software engineer who takes lot and lot of interviews at Google. So we'll do a live session with him. He'll share his experience. How did he crack Google? And he will also share how what are the expectations of an interviewer sitting in the opposite side of the table. What does he expect? How does he expect you to behave or to perform? And what are the expectations? What are the uh, things that the person or an interviewer look at, or what are the red flags? So do join that. I'll share the details in the Discord channel. So do join that with, live session as well. So I think that's about it. Thank you so much, guys. See you in uh, see you tomorrow and in the Discord community as well. Bye bye.